This is a focus stacking setup based on the Bratcam built by Chris Slaybaugh. Our setup is intended to be a very low-cost system. Apart from the optics and the electronics for automation, all of the parts are scavenged and cost us nothing. The entire electronic system was bought for less than £100. Our hope is that this system can be copied by other research labs who might wish to take deep focus, bright field images of their research specimens. If they already have access to photographic equipment and old microscopes, then this should be a fairly inexpensive setup to build, and it compares very favourably with the commercial alternatives, both in cost and image quality. The focus stacking setup is built using a commercial camera and some electronics, and with a lot of other scavenged parts. The rail is automated using an Arduino computer, and this part of the setup is described in the video called Automation of the Focus Stacking Rail. The rail itself is made from a focus block cut from a Nikon OptiPhot or LaboPhot microscope. The camera is then placed on top of the rail with the subject and lighting positioned accordingly. In building the system, we start with the automated rail, with the automation being described in the other video. To make the system cheap to build, the baseboard is a piece of worktop, and the focus block was cut from an old microscope. This cutting needs special equipment, but can be carried out in a metal workshop. The block is cut out using a band saw, and then the screw holes are drilled out and the threading is added using a tap and die. The plastic cogs were bought from an electronics shop, and the centres were cut out using a hacksaw. The cogs were then pushed out onto the stepper motor and the focus block knobs. We haven't found that anything further was needed to secure them. The base plate for the camera is then attached using a single screw. The plate is just a metal offcut from the metal workshop with a hole drilled. The next step is to add the optics. The camera body that we use is a Canon DSLR. Here, a film SLR body is being used as a stand-in as our DSLR camera is recording the video footage. In our system, we use a Canon 5D Mark II DSLR body, an Olympus Zuiko 200mm manual focus prime lens, and a Mitutoyo microscope objective, with a number of adapters in between. However, others have also successfully used objectives from the Olympus LM Plan F1 range. First, we put on the Olympus OM to Canon EOS adapter, and then the 200mm prime lens. After this, we add 2 UV filter rings with the glass removed, and then the microscope objective adapter. The UV filter rings are needed so that the long screw on the microscope objective does not hit the glass of the prime lens before it's fully screwed in. We found that this was crucial because if the objective was not fully screwed in, then it sat at an angle and the images were not sharp. Lastly, the objective itself is added. This is a Mitutoyo Plan Apo objective, which is optimized for bright field microscopy. We then prop up the lens using a piece of pencil eraser so that the long axis of the lens is exactly parallel to the moving platform. This step needs to be done quite carefully when setting up for photography. The next addition is the infrared remote control, which allows the Arduino to automatically trigger the camera between movements of the rail. Once the optics are all in place, we position the stand that will hold the photographic specimen. The diffuser for the lights is a polystyrene cup with a piece of black velvet as a photographic background stapled inside. The flashes are then placed in position, and the remote flash trigger is attached to the camera hot shoe. A piece of blue tack is added to the photographic support so that the specimen height and angle can be easily adjusted. The Arduino is then connected to the computer by a USB cable, and the power cord for the stepper motor is plugged in. At this point, the setup is all ready to go.